inequalities. Inequalities. We're starting on inequalities. So here I have 3x minus 4 is greater than 8. 3x minus 4 is greater than 8. When we are working with inequalities, there are 4 different signs that we can have. We can have our greater than sign. We can have our less than sign. Okay, and then we have 2 more signs that include equal to. So I've got greater than or equal to. And then I have less than or equal to. Most students remember those groups of signs. Okay, but having a sign, whether it's greater than, less than, greater than or equal to, or less than or equal to, that's what makes it an inequality, is that sign. Okay? Inequalities follow the same rules as equations. Inequalities follow same rules as equations. My advice is to move your variable to the left, and I'm going to show you why in a problem. I'm going to show you exactly why I encourage that in just a second. Then the last thing, when you multiply or divide both sides by a negative number, we reverse the sign. Now, it has been my experience that students remember some version of this. They remember having to do something, they just don't exactly remember what. And so at that point, students start getting confused and they make mistakes. So we're going to talk about exactly when you're supposed to do that today. Okay. So I am going to solve this inequality. I've got 3x minus 4 is greater than 8. So what I'm going to think to myself is I am going to think 3x minus 4 equals 8. So I'm going to think about it that way. And what would I do to solve this? Add 4 to both sides. That's what I would do, is I'd add 4 to both sides. So that's what I'm going to do. So then I'm left with 3x is greater than 12. Okay? So I'm thinking 3x equals 12. I'm going to solve it the same way I would solve 3x equals 12. What would I do? Excellent. I would divide by 3. Okay? So then I am left with x is greater than 4. And students are like, yep, I remember that. I'm good. Let's go. We're not done. Okay? Students typically do okay getting to this part. Unless there's just a whole bunch of fractions and it's super icky and all that kind of stuff. Students typically do okay. However, I want you to graph the inequality, and I want you to write the inequality in interval notation. So your answer needs to be in what is called interval notation. Okay, so I am going to graph and I'm going to write it in interval notation. If you think back to high school, you likely used open circles and closed circles when you were graphing. So my first open circle, and then my arrow goes to the right, is associated with greater than. Okay? My open circle, and then that goes to the left, is associated with less than. Okay? What if I have a closed circle and I go to the right? What does that closed circle mean? Good. Greater than or equal to. Okay, so then what does a closed circle going to the left mean? Less than or equal to. Now, we are not going to use open and closed circles. Okay? We are going to use interval notation. And interval notation takes the open and closed circle and replaces them. So if I've got greater than or I've got less than, instead of using an open circle, I'm going to use a parenthesis. The parenthesis tells me that whatever number I've got that parenthesis on is not included. That's what greater than and less than means. So here I've got x is greater than 4. Is 4 a solution to x is greater than 4? No. Okay, is 4.001 a solution?
Yes.
Yes. So that parenthesis tells me that that 4 is not included. That's why we use the parenthesis. You think of the parenthesis the same way you thought about that open circle when you were in high school. Now, here, I need something to replace the closed circle. Does anybody know what that is? It's a bracket. Good. Your bracket replaces the closed circle. So when I have a bracket, that means the number is included. Whoops. So when I've got the parenthesis, number not included. When I've got the bracket, the number is included. Okay? So I'm going to erase some stuff. Is it okay for me to erase? You guys got all this? Okay. So we're going to go back to our x is greater than 4. I always recommend graphing before you put your answer in interval notation. It is always a good idea because the graph helps you to dictate what the interval notation is going to be. So here we go. Here's my 0. I have 1, 2, 3, 4, 5. Okay, and then I can do -1, -2. So I am at +4. Am I going to put a parenthesis at +4 or am I going to put a bracket? Parenthesis, because my number is not included. So I'm going to put a parenthesis right there. That's what that parenthesis shows, is that number is not included. Now I am going greater than +4. So that means I go towards positive infinity. That's what that means. You can follow the arrow. Okay. We use the graph to write our interval notation. Where did my graph start? What number did my graph start at? No, this right here. My red graph. Where did it start? At 4. Okay? Do I have a parenthesis there or do I have a bracket? Parenthesis. So really my interval notation is just rewriting the graph. Where does my graph end? At what number?
Positive infinity.
Very good. Positive infinity. Okay? And your infinity is always going to have a parenthesis. Okay? So when you solve these, this is typically where students get to and they're completely fine. Okay? But I want a graph and I want it in interval notation. Okay? The graph is going to help you get to interval notation. Yes, ma'am?
You want to graph in interval notation when you do the homework?
Yes, please. Yes, because the graph is going to get you to the interval notation much smoother. Okay, let's do the next one. Can I go off this screen? Okay. Here I've got -2x plus 1 is greater than 5. -2x plus 1 is greater than 5. So I'm still going to isolate my variable. So I am going to do that by subtracting 1 from both sides. Then I'm left with -2x is greater than +4. My next step is to divide by negative 2. So I end up with x and negative 2. But I want us to look right here. What did I divide both sides by? Negative 2. Because I am dividing both sides, when I divide or multiply, both sides, that's a key word. Okay? When I multiply or divide both sides by a negative number, that is when I reverse the sign, or the symbol, the inequality sign. Okay? I'm going to write inequality instead of sign, because sometimes when we say, often when we say sign, we're thinking about the negative number. So my greater than becomes less than. And that is because I divided both sides by a negative number. Okay? Now I am going to do my number line. Here I've got 0. I'm going to go up to positive 2. Then I'm going to go to negative 4. So at negative 2, am I going to have a bracket or am I going to have a parenthesis? Good, because the negative 2 is not included. That's why. Okay, and then I am going to negative infinity because I am following what my inequality sign looks like. Okay, because it's less than. Interval notation. You always start here and you write what you come to first. That's the direction you go to when you're writing your inequality. So what number is way out here? What number?
Negative infinity.
Good. So I'm going to go from negative infinity to what number?
Negative 2.
Excellent. Okay. So I've got my answer when I have x is less than negative 2. Then I have graphed my answer. Then I have put it in interval notation. Okay. And I think ultimately your goal is interval notation. You do a significantly better job with interval notation when you graph it first. Graphing is a key component to that. Okay? Can I go to the next screen?
I got a question.
Sure.
I forgot why we flipped the infinity to the left side.
Okay? Because of this negative 2 that we divided both sides by. So anytime that we divide or multiply both sides by a negative number, that's when we reverse the inequality sign. Okay? Good question. Okay, here we go. Negative 3x plus 5x minus 2 is greater than or equal to 8x minus 7 minus 9x. Negative 3x plus 5x minus 2 is greater than or equal to 8x minus 7 minus 9x. Now, the first thing that I want to do here is I want to combine like terms on each side. I'm not going to start moving x's and I'm not going to start moving numbers until I have combined like terms that are on the same side of the inequality. So I am going to take negative 3x and positive 5x and add those together. Negative 3x and positive 5x give me positive 2x. Okay, then on my right-hand side of my inequality, I've got 8x and negative 9x. So I'm going to add those two together, and I get negative 1x. Okay? Now I'm going to start moving my variable to the left. Move my variable to the left. That is a very, very important habit to get into, is moving that variable to the left. So I am going to add 1x to both sides. And I've got 3x minus 2 is greater than or equal to negative 7. Okay, my next step is to add 2 to both sides. I have 3x is greater than or equal to negative 5. My next step is to divide by 3. Now, what number did I divide both sides by? Positive 3. So my rule is when I divide both sides by a negative number. The fact that I've got a negative on my numerator doesn't matter. What matters is that I divided both sides by positive 3. So I don't touch that sign because my 3 is positive. The fact that the 5 is negative doesn't matter. Okay? So then my answer is x is greater than or equal to negative 5 over 3. I am still going to graph that. Okay. So let's think about negative 5 over 3. Negative 5 over 3. I'm not asking you to change that to a mixed number. Okay? I'm not asking you to do that. In general, we leave negative 5 over 3 as negative 5 over 3. However, in order to graph it, we need to know where that falls on the number line. So negative 5 over 3, if I changed it to a mixed number, what would it be? How many times does 3 go into 5? Once. What do I have left over? 2. So negative 1 and 2/3. Okay? That's where it falls on the number line. Negative 1 and 2/3. So am I going to have a bracket at negative 1 and 2/3, or am I going to have a parenthesis? A bracket. Why? Okay? Because it says greater than or equal to. Because of this right here. That's why I have the bracket. Am I going right towards infinity, or am I going left towards negative infinity? I'm going right towards infinity. Okay? So my final answer here is negative 5 over 3, positive infinity. Now, our infinity and our negative infinity always uses a parenthesis. Always. Okay. Can I move off the screen? Okay. So now we have one that requires the distributive property. Okay. 3 times 2x plus 1 minus 2 times 2x plus 5 is less than 5 times 3x minus 2. So the first thing that we have to do is we have to distribute. Okay? So I'm distributing my 3. 3 times 2x is 6x. 3 times 1 is 3. Now, what am I distributing next? Negative 2. Students usually do fine with the first one. They do negative 2 times 2 is negative 4. Very often, they forget the negative on the second part. So it's got to be negative 2 times positive 5. What's negative 2 times positive 5? Okay. Then, 5 times 3x is 15x. 5 times negative 2. Okay. Now I'm going to go ahead and combine like terms. I've got 3x and negative 4x. Then I've got 3 and negative 10. 6x and negative 4x gives me 2x. 3 and negative 10 gives me negative 7. This is a situation where students are tempted to take this 2, subtract 2x from both sides, and move your variable to the right. It is mathematically fine to do that. There is nothing wrong with it, except we often make mistakes when we do that. And let me show you why. Okay? And then I'm going to show you the way I want you to do it. So I'm going to go ahead and I am going to subtract 2x from both sides. Okay? I'm going to subtract 2x from both sides. So I'm left with negative 7 is less than positive 13x minus 10. The reason that students are tempted to move that 2x to the other side by subtracting negative 2x is because then it keeps your x positive. And that's attractive. We don't like to deal with negative numbers. So it's attractive to subtract 2x from both sides because we then have a positive coefficient in front of our x. However, when I add 10 to both sides, I end up with 3 is less than 13x. I divide both sides by 13. And the answer that I get is 3 over 13 is less than x. That's the answer that I get. 3 over 13 is less than x is a correct answer. That is a correct answer. Here's the problem. This is what happens. Because we've got our x on the other side, this is where the mistakes start. You draw a number line. Here's your 0. Here's positive 1, positive 2, negative 1. 3 over 13 is a very small number. So it's going to be pretty close to 0. You look and you've got that less than sign. So you put a parenthesis right here. And because you see the less than sign, you go this way. That's the first mistake. This is not the correct answer. Okay? But the reason that we think it's the correct answer is because we have the less than sign in 3 over 13 is less than x. When we have x on the right-hand side, we actually have to read it backwards. And our brains don't like that. This is actually x is greater than 3 over 13. You have to read it backwards. Yes, ma'am?
Never mind, you just asked my question. Sorry.
Oh, I did. Okay. Now, there's a couple of different things that students do. Okay, one of the things students do is, oh, I can't have x on that side. I need to rewrite this. So they rewrite it as x is less than 3 over 13. That is still incorrect. So this is incorrect and this is incorrect. This is correct. We start rewriting things wrong. Do you see how my inequality sign is open towards the x? When I rewrite it, and this is the correct way to rewrite it, I take that x, I keep the inequality sign open toward the x. How does that read? Is greater than 3 over 13. Okay? So this right here is why I recommend always moving your variable to the left. Because then when you get your final answer, your variable's on the left, it's easier to graph, and when it's easier to graph, it's easier to put it in interval notation. So while you might get to this point right here with the correct answer, there's a high probability that this part and this part will be wrong if you're not very, very careful. Okay? So I'm going to erase. Can I erase and go back to 2x minus 7 is less than 15x minus 10? Can I go back? Okay. This is how I recommend that you do it. I recommend that any time that you have variables on both sides of your equation or inequality, that you always move it to the left. Always move it to the left. So I am going to subtract 15x from both sides, even though I'm going to have a negative coefficient. And that's okay. So then I have negative 13x minus 7 is less than negative 10. I'm going to add 7 to both sides. And I'm left with negative 13x is less than negative 3. Now, it's very possible that you might forget to reverse the sign here. That's very, very possible. But there's not multiple areas that you might make a mistake. And that's what happens when we move that variable to the right-hand side. If we move it to the left, this is the most challenging thing that we might have to deal with, is reversing the inequality sign because we divide by negative 13. When I divide by negative 13, I have to reverse the sign. So I have x is greater than 3 over 13. X is greater than 3 over 13. It is unlikely, if I get to this point, that I'm going to make a mistake when I graph or when I write it in interval notation, because I know how to read this. So I have x is greater than 3 over 13. I draw my inequality, or my number line. We already know that 3 over 13 is pretty close to 0. I put my parenthesis there, and I go to positive infinity because of the way my arrow is going. So my answer here is 3 over 13 to positive infinity. Okay? Okay. I got people asleep, so I need to wake everybody up. Okay. I want you to look and see what you have on. Look and see what you have on. If you have on blue jeans and a hat, I want you to stand up. Blue jeans and a hat. Blue jeans and a hat. Does anybody have on blue jeans and a hat? Really? I messed that up, didn't I? Blue jeans and a hat. Okay, so nobody did. Nobody has on blue jeans and a hat. Okay? Because for somebody to stand up when I say blue jeans and a hat means that they have to meet both criteria. They have to have on blue jeans and they have to have on a hat. Okay? And nobody in the class meets both of those criteria. If you have on blue jeans or a hat, I want you to stand up. Blue jeans or a hat, I want you to stand up. Okay. Now, we have a lot of people standing up for this because they only had to meet one of the criteria. They only had to meet either blue jeans or a hat. Thank you very much. Kind of wake yourself up as you're sitting back down. Okay? So, what we're moving into now is compound inequalities. Compound inequalities. Now, we combine compound inequalities with the word and or the word or. When we combine compound inequalities with the word and, our solution has to meet both of the criteria. Just like when I first asked people to stand up, the only people that could stand up were the people that had on both blue jeans and a hat. So you had to meet both criteria. We're also going to look at inequalities that are combined using the word or. Okay? If we use the word or, then the solution only has to meet one of the criteria. Either criteria. So we're starting with and. So here I have x is greater than negative 1. And x is less than 3. So I am going to draw my number line, and I am going to graph this on the same number line. So here's my 0. I'm going to go up to 5. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Okay. So now I am going to graph these on the same number line. Here I've got x is greater than negative 1. So the greater than means that I'm going to have a parentheses at negative 1. And then I am going to positive infinity. Okay? Now I am going to graph x is less than 3. So I am going to have a parenthesis at 3. And I am going towards negative infinity. Because I am using the word and here, because and is what I'm using for my compound inequality, my solution must be what covers both. So my solution is only this area right here because I've used the word and. So when I write this in an interval notation, it looks like an ordered pair. I start at negative 1 because negative 1 is the smallest number, and I go to positive 3. Negative 1, positive 3. And because I'm writing my answer in interval notation, that means that all numbers in between negative 1 and positive 3 are included. Is negative 1 included? No. Why? Because it's not a bracket. It's not, what was the other one? Yeah. It's not. Okay? It's not x is greater than or equal to negative 1. It's just x is greater than negative 1. So negative 1 is not included. Same for positive 3. Positive 3 is not included. Okay? Let's do another one. Here we have two inequalities. They are combined by the word and. So we are going to solve both of them. We're going to solve both of them. So my first one, I subtract 1 from both sides. I have 3x is greater than negative 6. Divide both sides by 3. And I'm left with x is greater than negative 2. I do not reverse the inequality sign. I do not. The fact that my numerator is negative does not dictate what I do to my inequality sign. It's the 3's. The 3's are positive, so I do not reverse it. It doesn't matter if the numerator is negative. It only matters if what I'm dividing both sides by is negative. Okay? I am combining using the word and. So here I've got 2x plus 5 is less than 7. I'm going to subtract 5 from both sides. 2x is less than 2. I divide both sides by 2, and I'm left with x is less than 1. Okay? I'm going to do my number line. Here's 0. I go up to positive 5 on my right-hand side. Negative 5 on my left-hand side. So, I'm going to graph x is greater than negative 2. I have a parenthesis at negative 2, and I go all the way to positive infinity. That's for x is greater than negative 2. But I am doing and x is less than 1. So I have a parenthesis at 1, and then I go all the way to negative infinity. So my answer is only what is covered by both. My answer is only what is covered by both. So to write my answer, I think about Moving on the number line from right to left. I start here. At negative infinity, do I have both? I don't have both. When do I start getting both? At negative 2. Okay? Negative 2 comes first because it's smaller. It's further to the left on the number line. That's why negative 2 comes first. Then I keep going, and what do I hit? When do I stop having both? At positive 1. Then I go to the rest of the way to infinity, but I don't have anything that covers both. So that's why my negative 2 comes first, because I come to it first on the number line. Okay, I have one more type of and to show you, and then we'll go into or. Okay, so here is another type of and that you will see, and it looks a little different. Okay, I don't have the word and written, so it does look different. So I've got negative 3 is less than 3x plus 1 is less than 7. Negative 3 is less than 3x plus 1 is less than 7. So I actually have 3 parts of an inequality. I have 3 parts of an inequality. When you have 3 parts to an inequality, it always means and. Always. And you can think about this being an inequality, and then you can think about this being a second inequality. Okay? So it really is 2 inequalities. The 3x plus 1 belongs to both. Okay? Now, my goal is to isolate the x in the middle. So whatever's in the middle with my x is what I'm trying to get rid of. And instead of doing the same thing to both sides, I do the same thing to all 3 areas. I do the same thing to all 3 areas. So instead of thinking about an equation having 2 sides or an inequality having 2 sides, think about it having 3 areas. And I've got to do the same thing to all 3 areas. So here I've got 3x plus 1. That's what's in the middle. So the first thing I'm going to do is I'm going to get rid of that 1. And the way I get rid of that 1 is by subtracting. Okay? So then I'm left with 3x in the middle. So then I just bring everything down. 7 and negative 1 gives me positive 6. Negative 3 and negative 1 gives me negative 4. Okay? My next step is to divide by 3. So I have negative 4/3 is less than x is less than 2. Okay. Now, to graph this, you are going to have your smaller number comes first. What's smaller, negative 4/3 or positive 2? Negative 4/3. So I am going to start at negative 4/3. So that's my negative 4/3 right there. It's a little past negative 1. Then I've got positive 2. So that right there is my answer. Okay? Your answer is what is in between these 2 numbers. What is in between these 2 numbers. And this right here always, anytime you see it written like this, it always means and. Always. So my final answer here, written in interval notation, is negative 4/3, 2. Negative 4/3, 2. Okay? Now let's talk about blue jeans or a hat. Blue jeans or a hat. This inequality is combined by the word and. This inequality is combined by the word and. I'm sorry, it's not combined by the word and. It's combined by the word or. I apologize. This is combined by the word or. Or is represented by this union sign. Okay? This is a union sign and it means or. So I'm still going to graph both of these on the same number line. Okay, so I've got my 0. So I've got positive 5 and negative 5. So I've got x is less than negative 1. So I'm going to have a parenthesis at negative 1. Okay. Then I've got x is greater than 2. X is greater than 2. So I put a 2 here. I put a parenthesis here. And then I go this way. To the right. Because it's x is greater than 2. Now, students typically do fine on graphing these. The problem is when we write it in interval notation. So when I write it in interval notation, I start down here and move from negative infinity to positive infinity. So what is right here at this very end, right here? What value? Negative infinity. And I'm going all the way to here. What number is right here? Negative 1. Then I have a union. Students aren't always sure what to do with that union. And I don't start again until I get right here. What's this? 2. And I go all the way to what? Positive infinity. Okay. And that's my final answer. We have time to do the last one. We ready? Okay. This is the same thing. Same general thing. We just have to solve it a little bit. I am still using the word or. I'm still using the word or. Okay? So what I've got to do is I've got to solve both of these. I'm solving both. So I add 5 to both sides. So I'm left with 2x is less than negative 6. I divide by 2. So I have x and I have negative 3. Do I reverse? No, I do not, because I'm dividing by a positive. The fact that that 6 is negative does not determine what I do with my sign. Then I'm combining using the word or. I'm going to solve this one. I subtract 1 from both sides. I'm left with 5x is greater than or equal to 5. I divide both sides by 5. And I'm left with x is greater than or equal to 1. So here's my number line. Here's 0. Okay. X is less than negative 3. So I have a parenthesis at negative 3, and I am doing less than, so I go towards negative infinity. For my second one, I have x is greater than or equal to 1. So what do I have there? A bracket. Okay, now I start on this end and I move to this end for interval notation. So I have negative infinity and I go to where? Excellent. What do I put in between? Union. That means or. Then I have a bracket on this side because I've got the greater than or equal to 1. Okay? And that is my final answer.